Hello, geometry students. In this lesson, we're going to continue and actually complete the lesson of proving triangles are the same, congruent, using a combination of their angles and sides. We did side, 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 angle, side, hypotenuse, leg already. And now we're going to talk about two angles and an included side, and then just two angles and a non-included side. So look at the first one. Two angles and an included side, you will have something that looks like that. Those two triangles will be the same. Furthermore, if you have two angles and a non-included side, then the two triangles will be congruent. You have to be careful about this one, though. It still has to be in the correct order. So look at this first one. Determine whether they are congruent. Write a congruent statement. I have angle, side, angle. Angle, side, angle. Angle, side, angle. That is a valid method. These two triangles are congruent. ABC. I started at the one that has one hash mark, went down to 2 by angle, side, angle. How about this one? I need 3 pieces of information. It looks like they've only given me 2, but I do know that that side is congruent to itself. So I have 1 hash mark, side, 2 hash marks. 1 hash mark, side, 2 hash marks. This is angle, side, angle as well. So the triangle statement, WXZ. I started out here at the peak. I went to the one that has 1 hash mark and ended up at the one that has 2 by angle, side, angle. How about this one? They didn't tell me anything about the angles on this one, but I know that this is congruent to that. And also a side is congruent to itself. So for some reason, side, side, side got thrown in. It is a valid method for proving. It just was unexpected. But that's okay. How about this one? Blue, side, orange. Blue, side, orange. Angle, side, angle. Those two triangles are congruent because of angle, side, angle. If you notice on this one, they're telling me that these are parallel. That means I've actually got some information about alternate interior angles. How about this one? The first thing you want to do is you want to look to see if these triangles look like they're congruent. You can't always tell because the picture may have been drawn by hand. This is actually one that I call butterfly or bat wings. If you look at this one, it looks like I don't have enough information, but I do have vertical angles here. So I've got 2 angles and a not included side. Make sure it's in the right order. So 2 hash marks, 1 hash mark, side. 2 hash marks, 1 hash mark, side. It's not quite a mirror. It is a mirror image of each other, but these are 2 angles and a non-included side. You can also say side, angle, angle, but that's not traditional. Because this is a weird one, I'm going to give the congruent statement. I started at the one that has 1 hash mark. I went down to the one that doesn't have anything and ended up in the middle. Angle, angle, side. Look at B. Careful. It looks like 2 angles and a non-included side. So congruent by angle, angle, side. But it's not. This is 1 hash mark, 2 hash marks, side. 1 hash mark, 2 hash marks, not the other side. This is not in the correct order. I don't know enough information about this. It must be exact. So I have 1 hash mark. In order for this to have been true, it would have had to been 1 hash mark, 2 hash mark. This would have had to be the side. But this was not done in the right order. So I don't know if they're congruent or not. How about this one? This one seems fairly straightforward. Angle, angle, side. Angle, angle, side. Regular angle, weird looking angle, side. Regular angle, weird looking angle, side. So 2 angles and a non-included side. That one works. Looking at B, right off the bat, I need at least 3 pieces of information. a side and a side and an angle, but I must have something else. There is not enough information on this. Typically, I would need to have something else, like they would be connected. They would have the same side or something like that. Like this. It looks like I've got vertical angles here, so I'm thinking side-side angle. But this is not in the correct order. These look congruent, but they're actually not provable. I've got an angle, a side, and then around here another side. An angle and a not the same side and a not the same side. So this one just falls apart on a lot of levels because it looks like it's angle, side, side. Well, that's not a valid method for proving, fortunately, for the geometry teachers everywhere. But also, this one just looks weird and twisted. This just doesn't look correct. I mean, this is a short side. It should go with this one. But that's all I need. It just doesn't work. So, cannot prove. Actually, I've been saying cannot determine. And I'm going to erase this because it wasn't even that. How about this one? It looks like we've got right angles. So I'm thinking hypotenuse leg. But this is the hypotenuse and they didn't say anything about it. So this is angle, side, angle, angle, side, angle. Not hypotenuse leg. How about going the opposite direction? Be careful on this one. What additional information is required to prove angle, angle, side? I got two angles and a non-included side. Well, I have the non-included side here. I also know that this is congruent to that. They look almost like right angles, but you can't be sure. I need an additional piece of information as an angle. This angle and that angle would not work because that would be angle, side, angle. That'd be okay, but that's not what it's asking for. So it must be this angle congruent to that angle. So what I would need to say is if angle Y is congruent to angle G, then angle, angle, side. That's the answer. If it were true that I said W and I, then this would be angle, side, angle. Whoops. It's true also, but that's not what the question was asking. Make sure you give me what I want. This one I want angle, side, angle. So I've got the side. I must have the angles at the opposite ends. I don't need to prove these two because these are vertical angles. So the only piece of information I would need is that C and T must be congruent. So if angle C is congruent to angle T, then this would be angle, side, angle. And that's that. Oops, it's not. I got one more. Say what additional information? Hypotenuse leg. It's the same one we did on the other one. I've got a right angle. I know that this leg is congruent. So if I know that this is congruent to that, so if VU segment is congruent to WD, then hypotenuse leg. That's the answer. How about side, angle, side? I've got a side. I've got another side. I must have the included angle. So the only one would be this one and that one. So if, must use three letters on this, angle VWX is congruent to NXW, then side, angle, side. And just so that you know, the good ones, side, 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 angle, side, angle, side, angle, side, angle. The bad ones, nobody makes all A's. And if you see this written on your paper, you know you've made a mistake. Here's why. If you look at this demonstration, I've got an angle and two sides. This angle is congruent to that. This side is the same length as that, but this side got swung out. So this is the swinging theorem. These two triangles are not the same. So I cannot prove it using angle side side because it could look like this. And then of course the nobody makes all A's, 60, 60, 60, a much bigger triangle. So that's that. Don't be that.